In the previous tutorial we had a look at the basic economic order quantity model, and we computed all the important aspects, such as, well, obviously the economic order quantity, optimal order quantity Q, and this was all from a theoretical point of view. Now we are going to take our first steps to actually apply this problem as well, this model. I mean, obviously there are these assumptions like linearity in demand, which is not very nice. And well, one of the basic aspects in applying the EOQ model is to reuse the order quantity and sometimes vary when exactly to order. Okay, so what do we need? What do we need? Well, first we need to know when do we want to do our orders. So we need to have a date. Let's also look at the day, which weekday that is. So date, let's start with the 1st of January 2016. I'm not sure whether any supplier will actually supply anything on that day. What kind of day is that? So let's format cells, and let's go to date, custom, and let's say we want to know the day. So it's a Friday, and we want to actually predict all of that for a whole year. So we go down all the way to unfortunately it doesn't go much faster, to the end of the year. Okay, here we are approaching the end of the year of 2016, and here we go. So date, then we look at all the days, and we would like to know when to make an order. So in our specification we said we only work 6 days in a week, and we don't work on weekdays. Sorry, and we only work on weekdays, not on Sundays. So we would like to know what is the number of such a day. So there it is this function which is called weekday, and if we enter a date and it gives us, then it returns to us the number. Okay, so now we can basically check as soon as it's Sunday that we are not going to include that, and everything which is not a Sunday we are going to include. So how do we do that? Simple if statement. If this one is equal to 1, then we don't include it, otherwise we count it. So is that a weekday? So now we are in the position to actually determine how many weekdays the year 2016 has. Let's first have a look of how many days do we have in 2016. So we got 366 days in 2016. Which is interesting. And how many weekdays do we have? Well, we need to add that all up. I'm just going to add it up in this way. There are other ways as well to do that. So plus the previous one, and so on. So we do see, as soon as there's the Sunday, we don't increase our account, and we are taking the last entry from there, which is 314. So we've got 314 weekdays. So weekday number. Good. So we determined that the cycle time is 61.2 days. There is the modulo function which would help us to immediately say when to reorder. So every time when there's when we can divide by 61, then we take that. So the modulo function. So modulo something with for instance 3, then we would expect whenever we hit 3 that we get a 0, and then it repeats itself again. So this is a nice identification for our cycle time. So let me use this one as the cycle time. So I'm going to round that with 0 decimals. Obviously it would be more precise to have 61.2, but here there's some imprecisions which we get now. So instead of the 3, I'm going to use now the 61. So let me replace that and have an absolute cell reference it, fix it, and go all the way down through there. So let's check 61. I expect it to restart. So this is when I place my order. So it's also interesting, when do we start with the ordering? If we don't have any stock, then we have to order on the first day or before the first day. Very doubtful that we get something on the 1st of January, but let's say we do. Okay. Then additionally we have got 6 bank holidays which we should consider. How could we do that? We could just really overwrite it and say that's actually a bank holiday, and say we're not going to work there. And that's how we could adjust it. So we need to figure out the 5 other workdays as well. Okay, so the order cycle day. Now we need to identify when we order. Okay. When exactly do we order? When the first day occurs. Okay. If OCD equals 1, then we reorder. Okay, how much do we order? That's an interesting point. The optimal order quantity is 2000. If this is not the case, then we don't order anything. So now we have got a little bit of a problem, because whenever there are consecutive days, we would order 3 times this quantity, which we don't really want. How can we get about that problem? That's quite interesting. By realizing that this 0 is actually exactly happening, so these repetitions are happening when we're not working. So just let's include an end condition. So end. So our first logical value, our second logical aspect is that this one should be greater than 0. Okay, let's drag this formula up and down. Good, so now we have got no repetitions. Let's see how much order quantity do we have in this year. $12,000. So that's a bit of a hammer, because we only wanted to have 10,000. We have only got a demand of 10,000 items. So what is actually our daily demand? Can we confirm that we are getting this 10,000? Let's have a look at the. So this is the order quantity and the demand. What is the daily demand? So if we have got 10,000 items and we have got 313 working days where we can actually get a demand, that means we have got a daily demand of 10,000 pallets divided by 313, 31.94. So obviously on a daily basis we don't have that, so we should put it into integers. So let's round that. So we've got a daily demand of 32 on weekdays. So 32 times, so when there's a weekday, 32. So on the bank holiday and Sunday we shouldn't have anything. Okay, what went wrong? No absolute cell reference. Here we go. And this gives us a total demand of 10,000. So why does that happen? Why is this happening? So just before the end of the year, there are a couple of days where we actually have this demand of 2,000. So this is pretty annoying. And we do know that there are only 5 orders. That means even if we artificially increase the cycle time by +1, we're still not going to move it over the threshold. Almost, but we haven't. So we have a little bit of an issue here. Okay. What are the holding cost and the ordering cost? Holding cost. So we have got 32 pallets. Good. 1 pallet costs 75 pence per year. So divided by that's an interesting point again. So actually we need to have a look at the inventory first. What is our inventory? Inventory. So the inventory is nothing else than the what we've got minus what we consume. So on Friday we received 2000 pallets in the morning and we consume 32. So at the end of Friday we have got an inventory of 1968, which we will be charged. Here again could be the other way around, that we have to pay immediately as something arrives. So that could mean that we would have to pay for the 2000 items rather than what we have at the end of the day. Okay, so now how do we get the next the inventory? How does the inventory grow or shrink actually? It's always the order quantity. It's always the order quantity plus what we currently have in stock minus what we consumed. We are paying for that on a daily basis. That means now we can compute the holding cost. So that's the number of pallets times the holding cost per year divided by the number of days, which is 366, and that's how much we pay on a daily basis. Obviously we have to use some absolute cell references again. And this gives us our holding cost. Let's have a look at the average inventory. So on average we have 1128, not quite Q half, but almost. 846 pounds, not quite 750 pounds, but almost. Could we have changed that by changing our cycle time to 63 days? Well, we would be short 16 items and we would have a lower inventory. Okay, holding cost 777, very close to the 750. Ordering cost, obviously that will be different because we had one extra order. Ordering cost. So this is happening if the order quantity is greater than 0, then we are going to pay 150 pounds. Again, absolute seller reference and otherwise 0. Okay, sum. So as expected it's higher. If we change the cycle time to 63 days, then it's exactly 750 pounds. Okay. So this gives us the total ordering cost. Good. This almost completes our tutorial with getting the real ordering dates. I mean, we can now see when we have to order. So whenever this is greater, whenever we incur the ordering cost, then we are going then we are ordering. So we can plan ahead and say, okay, we need to order on the 15th of March. So that means basically we are getting hold of our correct ordering dates. We could obviously have approximated them by going immediately on the weekdays rather than on the cycle days. And we have an idea of how much we have spent on holding costs and how much we have spent on ordering costs at exactly what time. So we can just aggregate those costs. We can also actually see how the inventory develops. So we can just insert a graph. Let's insert a line graph. Insert line graph. So that's good enough. And we see nice and neatly what the EOQ is doing. And we do see the average inventory is roughly at 1000, and the replenishment is instantly. We do see a slight increase in the inventory, which we have. Obviously this is due to our imprecision and of the days. Alright, I hope you enjoyed this tutorial, and I'm going to looking forward to seeing you to the next one.